Hi, I'm Derek Downey, a developer advocate for Google Cloud. I am excited to share some great news if you are using Cloud Spanner and have downstream systems that need to be aware of data changes in near real time. Getting data changes from one system into another, especially in real time, can be challenging. To address this, Cloud Spanner just released change streams to make it easy to set up pipelines to process changes made to your Spanner data. In this video, I will explain what change streams are and what is required to set them up. Then I will show you how easy it is to set up a change stream and a pipeline to process changes made to your Spanner data into a downstream BigQuery analytics environment. Finally, I'll go over some typical use cases for change streams and how Spanner makes it easy to enable those use cases. So what are change streams? If you have ever heard of change data capture, or CDC, that's a good starting point for understanding change streams in Cloud Spanner. Change streams keep track of changes made to data through DML or Spanner mutations that can then be processed by pipelines to publish in a downstream system. There are many reasons you might want to get data changes from one system into another. You might have a data warehouse and you need real time information to improve business decisions. You might want to trigger downstream application workflows. For instance, restocking an item if the inventory level drops beneath a threshold. You might have a need to keep an audit trail of changes in a separate system for compliance purposes. Or perhaps you want to keep track of changes for disaster recovery. Whatever the reason, the process to set up a change stream in Spanner is straightforward. First, create the change stream in your database. A change stream is another type of object in Spanner, like a table or a secondary index. So you can add, modify, or delete change stream objects using DDL. You can create a single change stream for all tables in a database, or you can create a change stream for specific tables, or even specific columns within those tables. Second, you need a destination to receive the changes. This can be BigQuery, Google Cloud Storage, Google PubSub, or any other system to receive the stream of changes. And finally, you set up a pipeline to process change events from the change stream in Spanner and publish to your downstream system. You can easily build data flow pipelines to process the change stream events leveraging SpannerIO from the Apache Beam repository. Or you can connect directly to the Spanner API and write your own processing logic. This might be best to explain with an example. I currently have an inventory service for an e-commerce store that is backed by Spanner. I also have BigQuery set up to track inventory behavior over time. Having this analytics environment has enabled me to make good decisions on what items to keep in stock. Currently, to get data from Spanner into BigQuery, I had to set up and maintain additional pipelines to extract the data in batches before loading into BigQuery. These batches cause some delays that have caused headaches for my analysts. With change streams, I can move to almost real-time streaming of data changes into BigQuery and simplify the logic for processing. To set up my change stream, I go into the Cloud Console page for my Spanner instance. Then I add my change stream via the DDL page. The syntax is fairly straightforward. You need a change stream name. Change stream names are unique to the Spanner database. Next, you specify the entities you want to track in this change stream. You can track the entire database, a set of tables, or specific columns for tables. Last, you specify the retention period for change stream data. The records that are tracked are stored for this retention period before automatically cleaning up. By default, the retention period is 24 hours, but can range up to 7 days, and you'll pay only for the additional storage required to keep the change events longer. Now, I also have my BigQuery environment set up that is used for inventory analytics. All I have to do is set up the Dataflow pipeline for BigQuery. So I go into Dataflow in the Cloud Console, then create a new pipeline. I provide the pipeline and name. The region I select is US Central 1 to be near my Spanner instance. And then I select the Cloud Spanner to BigQuery template. This template leverages the Apache Beam SpannerIO connector. Here, I need to provide some more information. First is the Spanner instance name and database name. This is the location of the ChangeStream object I created earlier. Next, I need to provide a metadata instance and database name. This is needed for the SpannerIO connector to keep track of the changes it has processed. The metadata instance and database can be the same as where the ChangeStream is located, but I'd recommend at least storing the metadata in its own database. Once we've provided the metadata location, then we provide the ChangeStream name. And finally, I specify a BigQuery dataset to store the data changes. There are some optional parameters, but this is enough to get started processing the change streams from when the pipeline is created. That's it. After a few minutes for the pipeline to get set up, I will start receiving data changes into BigQuery. As part of releasing change streams, the Spanner team has also released SpannerIO to the Apache Beam repository. SpannerIO can be used to process data change events from Spanner change streams. There are also 3 main data flow pipeline templates available that leverage SpannerIO to quickly get started processing Spanner change streams. The first is the BigQuery template that I just walked through. This allows you to set up BigQuery to receive changes from Spanner in near real time. There is also a Google Cloud Storage template. One example of sending data changes to cloud storage would be to keep an audit archive of detailed change events on important data for regulatory purposes. And finally, there is a template to publish data changes to PubSub. This is useful to trigger workflows in external applications that are listening on a downstream PubSub related to those changes. If you need to publish data changes to another destination, or if you need additional processing of the data changes, then you can create a custom pipeline that leverages the Apache Beam SpannerIO connector. It is also possible to connect directly to the ChangeStream API to create a customized data pipeline without using the SpannerIO connector. It's possible to have multiple change streams in the same database, and even multiple change streams tracking the same tables or columns. Here are some things to keep in mind with multiple change streams. You can have up to 10 change streams per database, and up to 3 change streams can track the same non-key column. You should maintain no more than 5 concurrent readers for a change stream partition, or performance may degrade. Change streams is a great new feature in Spanner that enables real-time data pipelines based on data changes. I have shown how to set up a basic pipeline to get Spanner data changes into BigQuery using the available Dataflow template. There are many ways change streams can be leveraged, from triggering downstream application workflows using PubSub, storing data within cloud storage to enable data recovery, or for setting up an audit trail for compliance purposes. Let us know in the comments how you're using change streams, and if there are other templates you'd like us to provide in the future.